All right, so today we're going to talk about inscribed angles. So let's go ahead and look at central angles again. So remember, a central angle, the vertex is at the center. And so here's our diagram. We have two radii, and remember that the measure of the angle is equal to the measure of the arc. So we could say the measure of angle AOB is equal to the measure of arc AB. So that's one way that we could write that. And for an inscribed angle, the vertex is on the circle. And so for this one, we label this, X, Y, and W. So the measure of the angle is half the measure of the intercepted arc. So for this one, we would say that's the measure of, it's actually right up here, so the measure of angle WXY is equal to half the measure of the intercepted arc. So the arc is WY divided by 2. So you could also write that as the angle is equal to the arc divided by 2. So make sure to add that to your graphic organizer that we looked at the other day. So let's go ahead and look at 4 different ways to an inscribed angle could look. So here we have the angle, and that would be the arc. Here's the angle in the arc, and here's another example. And this last one, we have, again, the vertex is on the circle, so this would be the intercepted arc, the highlighted area. Next, it says, consider the central angle shown. Use a straight edge to draw an inscribed angle that contains point A and B on its sides. Name the vertex at your angle point P. What do the angles have in common? All right, so there's our drawing. And so what do we notice that the angles have in common? You'll notice that they share the same intercepted arc right here. So the same intercepted arc, which of course in this case would be AB, or you could say of course BA. Makes sense that if the measure of angle AOB is 96 degrees, what is the measure of arc AB? Well, we know that this measure of angle AOB, that's a central angle. And we know for central angles that the measure of the arc is equal to the central angle. So that means that the measure of arc AB is equal to 96 degrees. So that means this would be 96 degrees. And the next question is asking us, what is the measure of angle APB? So remember we said for APB, that's the inscribed angle. And so the angle is equal to the arc divided by 2. So in this case, the measure of angle APB is equal to the arc, which is 96 degrees divided by 2. So 96 divided by 2 is 48 degrees. So that means that this measure would be 48 degrees. So the next question says, what can you conclude about inscribed angles that have the same intercepted arc? So if we were to draw another inscribed angle on our circle above, so I just drew another angle A and B. So we can conclude that if an inscribed angle has the same intercepted arc, they will be congruent. Angles. So that means that angle P is congruent to angle N in this case. So that means this is also 48 degrees. And no matter where I put that point, as long as it's an inscribed angle with that same arc, they will always be congruent. So I could, of course, have drawn a point on this other side over here. So let's go ahead and find the indicated measures. So we want to find the measure of arc BC, which is right here. So we'll notice that we were given this inscribed angle as 37 degrees. So remember that the angle equals the arc divided by 2. So in this case, we have the angle, which is 37 degrees, equals the arc divided by 2. So if we multiply both sides by 2, 2 times 37 is 74 degrees is equal to the arc. So that means that BC is equal to 74 degrees. For the next one, we have the measure of angle A is what we're looking for, and we're given the measure of this arc BC is 158 degrees. So again, it's an inscribed angle because we're looking for this angle measurement right here. So remember again, the angle equals the arc divided by 2. So the angle we're trying to find, which is A, is equal to the arc, which is 158 degrees divided by 2. So when you divide, you get 79 degrees. Looking at the next one, we want to find the measure of arc 1 and 2, and we are given this inscribed angle is 117 degrees. So this right here would be arc 1. So arc 1 we'll look at first. So again, remember that the angle equals the arc divided by 2. So in this case, the angle is 117 degrees equals arc 1 divided by 2. So multiply by 2 and you get 234 degrees equals arc 1. And now if we want to find the next arc, which would be this side over here, arc 2, so that means that if we know arc 1 is 234 degrees, a couple ways we can solve this. We know that the full circle is 360 degrees, so that means that arc 2 would be equal to 360 degrees minus arc 1, which was 234 degrees, which gives us 126 degrees. Another way we can find that is using supplementary angles. So we know that this angle right here is supplementary to 117. So if you take 180 minus 117, that tells you that this angle right here is 63 degrees. So then you could take 63, multiply that by 2, and you get 126 degrees. So two different ways of doing that problem. All right, so go ahead and pause the video, see if you can do 8 and 9 on your own. When you're done, unpause the video to check your work. So we're finding the measure of angle 1, given that we have this arc. So of course that's an inscribed angle. So for this we have 164 degrees. So remember the angle equals the arc divided by 2. So the measure of angle 1 is equal to 164 degrees divided by 2, which is 82 degrees. We're trying to, for the next one, find the measure of angle B, which is right here. So we would need that angle. And we weren't given any measures here, so how can we find the angle? Well, if you'll notice that AC is a diameter. So if AC is a diameter and it intercepts this arc right here, so that arc goes also with BC, well, remember that the diameter means that's half a circle, so half of 360 is 180, and that's a central angle. So that means this is 180 degrees and this is 180 degrees. So now that we have that measure, we can figure out that, again, the angle equals the arc divided by 2. So that means the measure of angle B equals 180 degrees divided by 2, which is, of course, 90 degrees, and that means this is actually a right angle. Anytime you have a diameter like that and it intercepts the same arc for inscribed angle, it'll always be 90 degrees. All right, so now we're going to use multiple steps to find the indicated measures. So we want now the measure of arc AB, which is right here. So to find that, what do we know? We know that this inscribed angle is 27 degrees, which means we can find arc BC. So remember that the angle equals the arc divided by 2. So 27 degrees equals arc BC divided by 2. So if I multiply that by 2, we get arc BC is equal to 27 times 2, which is 54 degrees. So now I know this is 54 degrees. I also know that the central angle BOC is also 54 degrees, but we're not trying to find that, so it's not necessary. And so we want to find what AB is. So something we do know is that AC is a diameter. And so that means that this measure right here, that arc, is 180 degrees. And we know this one's 54 degrees. So we know there's 360 degrees in the circle, so we can use that to help us solve. So we have 360 degrees minus 180 degrees minus 54 degrees, which is equal to 126 degrees for the arc AB. Of course, you didn't really have to do 360 minus 180 because we know it's half the circle. You could also just do 180 minus 54 and get 126. That would also work. Looking at the next one, we want to find the measure of angle A, which is right here. So how do we find that measure? We know that we have this central angle is 132 degrees, which means that this arc BC is 132 degrees. So again, the angle equals the arc divided by 2. So angle A measure is equal to the arc, which is 132 degrees divided by 2, which gives us 66 degrees. Again, don't forget to make sure you label your degree symbol. All right, so for the next problems, why don't you pause the video and see if you can do these on your own. For 12 and 13, then when you're done, unpause and we'll check our work. So for question 12, we're looking to find this angle measurement for 1, and we are given that this arc is 128 degrees. So we know that the angle equals the arc divided by 2. So the angle for 2, in this case, I'm just going to say the angle is equal to 128 degrees divided by 2, which tells us that's 64 degrees. So angle 2 equals 64 degrees. So I can find angle 1 because I know that angle 1 and 2 are supplementary angles. So the measure of angle 1 is equal to 180 degrees minus 64 degrees, which gives me 116 degrees. Of course, that's not the only way you could have done this problem. we know a full circle is 360 degrees. So if we know that this measures 128, we can figure out this arc measure by taking 360 minus 128, which gives us 232 degrees. And so the angle equals the arc divided by 2, so 232 divided by 2 is 116. So that's a second way to solve. Looking at question 13, we're looking to find the measure of angle C. I would like to highlight because it helps me visualize what I'm trying to look for. We are given that this inscribed angle, because the vertex is on the circle, is 50 degrees. So if we know that's 50 degrees, that means we can figure out this arc right here, AC. So remember that's the angle is equal to the arc divided by 2. So that means 100 degrees is equal to the arc AC. And if we know that is 100 degrees and we know that BC is a diameter, which means that this entire arc from here to here is 180 degrees. So the measure of arc C AB equals 180 degrees. Then we can figure out what AB arc is. So the measure of arc AB is equal to 180 degrees minus 100 degrees, which equals 80 degrees. So we know that this arc right here is 80 degrees, and that we needed to know because that is where our angle intercepts our arc. So now we can go ahead and figure out the measure of angle C is equal to the angle, or the arc, sorry, which is 80 degrees divided by 2, so 40 degrees would be this angle right here. Looking at question number 14, we're trying to find first x. So to solve for x, we are given this inscribed angle is 42 and the arc is 4x plus 2. That's the intercepted arc. So again, remember that the angle equals the arc divided by 2. So 42 degrees is equal to 4x plus 12 divided by 2. Multiply both sides by 2. And we get 84 is equal to 4x plus 12. Subtract the 12. And we get 72 equals 4x divided by 4. And that means x is equal to 18 degrees. So now we know x is 18 degrees. And we also know that this whole arc is equal to 84 degrees because we know that 42 times 2 is 84. Or you could plug 18 in for x and you would get 84, same thing. And so we want to find arc AC, so we just said that was 84 degrees. And now we want to find this arc right here, BC. So again, we know that there's 360 degrees in a circle. So BC arc is equal to 360 degrees minus 84 degrees minus 58 degrees, which is equal to 218 degrees. All right, so I think there's one last question. So let's go ahead and take a look at this. For this last question, see if you can try to do this one on your own when you're done on pause video, and we'll check our work. So first, let's go ahead and see the information we have. Notice that there are lines right here and here. That means that those arcs AB and AC are the measures of the arcs are equal. And so we're going to use that to help us solve. So before we do that, we can solve for x because we have the angle equals the arc divided by 2. The angle is 3x minus 16 equals the arc, which is 4x plus 14 divided by 2. So multiply both sides by 2 first. We're going to have to distribute that 2 to each of these terms here. So we get, oops. So when we do that, we get 6x minus 32 equals 4x plus 14. Let's go ahead and subtract the 4x. So 2x minus 32 equals 14. Add the 32. So that means 2x is equal to 46 divided by 2. And x is equal to 23 degrees. So now that we have x is 23 degrees, we can go ahead and start solving. So we can solve for angle A, because angle A is equal to 3 times 23 degrees minus 16. We're just plugging in our x, which gives us 53 degrees. And arc BC we can find, so measure of arc BC is equal to 4 times 23 degrees plus 14, which is 106 degrees. And lastly, we want to solve for arc AB, which is here, but we know that this arc measure and this arc measure are equal. So we know x plus BC, which we just said was 106 degrees, should be equal to 360 degrees, because we know a full circle adds up to 360 degrees. So this gives us 2x plus 106 is equal to 360 degrees. So 2x is equal to 254 degrees when we subtract 106 and divide by 2, and x is equal to 127 degrees. So 127 degrees, that means that both arc AB and if we were asked to do AC, so arc AC is also equal to 127 degrees. And that is all for our inscribed angles. So again, don't forget to make sure to add those definitions to your graphic organizer.